Hello friends, welcome back to our channel. This is Rohit. Friends, in today's video we are going to talk about topic sensors in Android. So in this video friends, first of all we will understand the concept of sensor. Then we will understand what various types of sensors available. Then next to that we will see what is sensor framework and what different classes and interfaces are available to work with sensors with their methods. And at last I will show you one practical example how we can implement sensors in Android application. So friends, let's start the video by understanding the concept of sensor. Now first of all we need to understand that sensor is a device. It is a hardware, and this device or hardware is actually sense or measures the different inputs from physical environment. So this device is responsible for sensing, this device is responsible for measuring, or this device is responsible for detecting the change in the input. So from where this input is coming? So input is coming from the physical environment. Now once the device has detected or once the device has sensed the input, then next to that it will convert it into certain useful data. So this data will be interpreted by either machine or by either humans, and based on interpretation, based on analysis, we may take certain decision, we may take certain action. That is basically the concept of sensor. So here the word physical environment we have referred. So physical environment means in which we are living. So in the physical environment there are different entities, there are different things that we can sense, that we can measure with help of sensors. So what different things we have? So we may have light which can be detected, which can be sensed using the sensor. We may have heat, we may have motion, moisture, pressure, temperature. So many things are there from physical environment that can be sensed or that can be measured with help of these devices which are referred as sensor. So for example, based on what kind of input the device is sensing or device is measuring, based on that there are different types of sensors. So let's say if the device is sensing and measuring the light, then it will be referred as light sensor. If the device is sensing or measuring motion, then it will be referred as motion sensor. Like that, there are different types of sensors based on what kind of input data they are sensing, they are measuring, or they are detecting. Now let's move forward and let's understand in context of Android what sensors are. So nowadays whatever mobile phones we are using, all that mobile phones are powered with built-in sensors, and these sensors will be used for variety of reasons, for variety of tasks. For example, they can be used for measuring the motion of device, orientation of device, or there are so many other things as well for which the sensors in our Android phone can be used. So the sensors basically capable for providing raw data that is coming from physical environment we just talk about, with the high precision value and high accuracy value. So whatever raw data is coming, that raw data can be used for monitoring the three-dimensional device movement, how your mobile phone is moving. Then raw data can be used for monitoring the positioning of our device, or it can be used for monitoring the changes in the ambient environment near to the device, like light may be there, temperature may be there, humidity may be there. So all these things can be monitored with help of raw data that is coming from sensors. So one thing we need to note here, that this raw data is having high precision value and high accuracy value. That's why taking such decision or monitoring all these different activities will be very easy. Now here we have different examples, real-time examples where sensors are really useful. So first example is regarding game. So whenever we play any game, so that game may track the readings from device gravity sensor, and with help of gravity sensor the game can identify the complex gestures of users like tilt, shaking phone, rotation or swing. All this can be detected and can be used for performing different actions. Now second example, we have a weather application. So a weather application may use device temperature sensor and humidity sensor for calculating and reporting the dew point. And third example, we have, let's say we will have a travel application. So this travel application may use the geomagnetic field sensor and accelerometer for reporting the compass bearing. Okay, so these are all the real-time examples where sensors are playing very important role, and based on sensors data that applications are doing certain tasks or that applications are making certain decision. So these are the common uses of sensors. Now next to that, let's try to understand what different types of categories the Android platform supports. Now Android platform supports three broad categories of sensors. So first category is motion sensor, second category is environmental sensor, and third category is position sensor. Three categories in which the sensors are categorized. Now first category we will try to understand motion sensor. Now these sensors are used for measuring the acceleration forces and rotational forces along the three axes. Now which three axes we are talking here about? So let's say this is your Android device. So in context of this Android device, this will be your x-axis, this will be your y-axis, and towards user this will be your z-axis. Here the user is available. So along all these three axes, the acceleration and rotation can be measured with help of motion sensor. Okay, now what are examples of motion sensors? So it includes accelerometer sensor, gravity sensor, etc. Now second category we have environmental sensor. Now these sensors are used for measuring different environmental parameters like ambient air temperature, pressure, illumination, humidity, etc. Now what different examples we have which are available in this category? So there is a barometer, photometer, thermometer, etc. So this is second type, environmental sensor. Now third category we have position sensor. So these sensors are used for measuring the physical position of device. So this sensor includes orientation sensors and magnetometers. So these are the three broad categories in which the sensors are categorized in the Android. First type we have seen motion sensor, second type we have seen environmental sensor, and third type we have seen position sensor. Now we can access these all available sensors on the device and we can acquire the raw sensor data by using the Android sensor framework. So in order to work with any of these above type of sensor, there is an Android sensor framework available. Now in this framework, different classes are available and interfaces are available. Classes and interfaces. So these classes and interfaces will help you in order to work with specific type of sensor, and it will also help you to get the raw data from sensor. So once you receive the raw data from sensor, you may perform different task or different action, whatever your application required based on that data. Because at the start of this video we talk about this raw data which is coming from sensor, and this raw data is having high precision and high accuracy. That's why important decisions your application can make based on this raw data that is coming from this sensor. So here we need to remember there is an Android sensor framework available. So what different classes will be available in this, we will see shortly. Now move forward. Now in the sensor framework, as I told, there are different classes and interfaces available, and these classes and interfaces will be used for performing different tasks related to sensor. Now what task you will be able to do? First task here we have enlisted. We can know which different sensors are available in specific device. So as we discuss, different Android devices having different types of sensors. So in specific Android device, which different sensors are supported, which different sensors are available, that we can determine, that we can know with help of this sensor framework. This is the first thing. Second thing, we can determine individual sensors capability, what that sensor can do. So this capability includes, let's say, its maximum range which it can recognize, the manufacturer, the power requirement of sensor, and the resolution. So we can also determine the precision value of sensor, accuracy value of sensor with help of sensor framework. The next thing we will be able to do is acquiring raw sensor data. That is the most important thing that we will be able to do. So whatever data our sensor will sense and our sensor will detect, we will be able to acquire that data, we will be able to receive that data, and we may also able to define the minimum rate at which the data should be sensed, the data should be received. Okay, so that is called sensor delay actually. So sensor delay as well we may able to specify. This is the third thing. So in third thing you need to remember, we will be able to acquire the raw data from the sensor. And next thing we have that we will be able to register and unregister the sensor event listeners. So whenever sensor will send certain kind of data, whenever sensor will detect change in data, then that change in data will be recorded with help of sensor event listeners. So that continuously monitors the change in the value of sensor. So for registering and unregistering this sensor event listener, we will use the sensor framework and its classes. Okay, so these are the things that you will be able to do with help of sensor framework. So regarding sensor framework, one important note we have to remember that it contains the classes and interfaces that will be used for working with different types of sensors that are available in the Android device. Okay, and these are the various things. So first thing, you can determine the all available sensors. Second thing, you can get the all details of sensor that we are saying as a capabilities of sensor. Third thing, we can receive or we can acquire the raw data, and as well we will be able to specify the delay at which data should get received. And last thing, we will be able to register and unregister the sensor event listeners. So next to that, we have to understand, so some of the sensors are hardware based and some of the sensors are software based. So these are the again two categories you can say in the Android. So hardware based is the first category and software based is the second category. Now let's try to understand what do you mean by hardware based sensor and what do you mean by software based sensor. So first of all, we have hardware based sensor. Now these are the sensors which are actually physical components built in our handset or built in our device. So these are the physically present sensors within our mobile phone or within our handset. That's why these devices are called hardware based sensors. Physically it is present. That's why it is called hardware based sensor. These sensors are retrieve the raw data directly by measuring specific environmental properties. So already we told you about different environmental properties or things that sensor can sense. So light may be there, temperature may be there, humidity may be there, heat may be there. So different properties can be directly sensed by these hardware components. That's why these are called as hardware based sensors. Now here example we have given acceleration, geometric field strength. These are the examples of hardware based sensors. And second category you have software based sensors. Now these sensors are not physically present within our mobile phone or within our handset. That's why here we are saying software based sensors are not physical devices. So they are actually mimicking or they are actually copying the hardware based sensors behavior. So software based sensors retrieve their data from one or more hardware based sensors. So software based sensors are depend on hardware based sensors for retrieving their data, and hardware based sensors are depend on environmental properties for retrieving their data. This difference we have to understand here. So software based sensors are also called as virtual sensor or synthetic sensor. Why these are virtual sensor? Because physically they are not present. That's why they are called as virtual sensor or synthetic sensor. So from their name we can understand the difference here. Software based sensors, these are the virtual sensors and which are depend on hardware sensors for getting their data. And hardware sensors, these are available in form of certain physical component, chip you can say, which are directly recording data or detecting data from the environmental properties. So here example of software based sensors are linear acceleration sensor, gravity sensor. These are the few examples. So two categories you will remember here: hardware based sensors and software based sensors. Now next to that, so few Android powered devices having every type of sensors. For example, most of the handset devices and tablets are having accelerometer sensor, magnetometer sensor, but only few devices is having, let's say, barometer or thermometers. So now we will try to understand what different classes and interfaces that is provided by the Android sensor framework for acquiring the raw data from the sensors. So very first class we have sensor manager class. So this class is used for creating the instance of sensor service. Now there are different types of services available in Android. So sensor is one of service which is available within the Android. So in order to create the instance of sensor service, we can use sensor manager class. So this class providing methods for accessing and listing sensors, for registering and unregistering sensor event listeners, and acquiring the orientation information regarding the device. So this is basically the role of sensor manager class. Now here one example we have given how we can create the instance of sensor manager class. So sensor manager is a class name and SM, that is sensor manager, is a object name. And here we are using one method, get system service. So this method is used for acquiring the system service, and which service we want to access. So here we want to access the sensor service of our system, and we are typecasting the result in the sensor manager type. So this is how we can create the instance of sensor manager class with help of get system service method. So here we need to remember, to this method we have to pass the sensor service as a parameter which is defining the sensor service in the Android device. Now second class we have sensor class. Now this class is used for creating instance of a sensor. So we can create the instance of any sensor. So how we can create the instance? So here it is example. So how we can create the instance of sensor? So here we have to write class name sensor, and you can specify the object name here, any name you may specify. So the recommendation is that whatever type of sensor you want to use, based on that you should specify the object name here. Let's say I am using here type light sensor, so my object name will be sensor light, like this. So this is how we can specify the object of sensor class. And here we are calling one method of sensor manager, that is get default sensor. So SM is an object of sensor manager as we know, and get default sensor is a method of sensor manager class. So this method basically returns the specific type of sensor that we want to work with. So here we have specified the type light sensor. So sensor dot type light. So this name, this constant is specifying the name of our sensor that we want to use. So this is how we can create the instance of sensor class. And this class also provide you variety of methods that will help you to determine the capabilities of sensor. That already I told you. Maximum range may be there, accuracy may be there, precision may be there. All such capabilities of sensor can be determined with help of different methods of sensor class. Now third class we have sensor event class. Now this class is used for creating the sensor event object. Now what is job of this sensor event object? So whenever sensor will sense certain data, whenever sensor will detect certain data from different environmental inputs, then that can be detected by the sensor event object. So this class will be used for retrieving the raw sensor data, the type of sensor that is generating the raw data, the event, the accuracy of that data, and the timestamp at which the event occurred, the data recorded. All these things can be retrieved from the sensor event object. So this sensor event object we will use within the methods of sensor event listener. So method may be on accuracy change or on sensor change, that we will see shortly. So within the methods of this sensor event listener, we will use this sensor event object, and this object will contain different data regarding sensor. So next to that interface we have sensor event listener. So this interface is available with two callback methods. As I told, first method is on accuracy change and second method is on sensor change. So these two methods will receive the notification about the sensor events whenever sensor value will be changed or whenever sensor accuracy will be changed. Before moving further, I will just try to tell you little bit information regarding accuracy and regarding precision. So here the accuracy of sensor means the maximum difference that will be exist between the actual value. Now this actual value must be measured by using certain primary or secondary standard, okay, and the indicated value at the output of the sensor. So the difference between actual value and the value that is given by sensor at the output, so their difference is nothing but the accuracy. So this accuracy can be expressed in the percentage form or in the absolute value as well. And precision is about how close all the sensor readings are grouped and what methods this interface is providing. So first method we have on accuracy change. So this is the signature of this method, void on accuracy change. It requires two parameters. First one is the object of sensor and second one is the accuracy. Now this method will be called whenever there will be change in the accuracy of measurement of the sensor. So this method will provide you the sensor object and this accuracy will have the four possible values. So first possible value is sensor status accuracy low, sensor status accuracy medium, high and unreliable. Any of these value may be written by the sensor. Okay, now this is the first method on accuracy change, and second method we have on sensor change. Now whenever there will be any new reading value will be available from sensor at new timestamp, then this method will get invoked. So its signature is void on sensor change and it has the object of sensor event class. Event is object. So this will be called whenever sensor value will be changed. So this method will be called whenever there will be availability of the new sensor data with new timestamp. This is the most important point regarding this method. So whenever new data is coming from sensor, it is recorded with the timestamp. So latest value of sensor can be determined, can be retrieved. This method will provide us the sensor event object that contains all the raw data of the sensor that it has written. So in our example, we are going to implement both of these methods of sensor event listener. So first method you remember on accuracy change and second method you remember on sensor change. So these are the classes and interfaces that are available in the sensor framework. So first class we have seen sensor manager class, second class we have seen sensor class, third class we have seen sensor event class, and fourth we have seen sensor event listener interface and its two methods, accuracy change and sensor change. Now few important points that you need to remember while working with sensor. First point is you should always gather the sensor data in the foreground. Second point, whenever sensor data is not in use, then you should unregister the sensor listener, so it will not run in a background and it will not drain your battery. So if it keep running in the background, then it will keep consuming your battery and it will drain it very soon. That's why whenever your sensor is not in use, definitely you should unregister it. Third thing, before collecting data from specific type of sensor, make sure that sensor is present within the device. If it is present, then only go for collecting data. Otherwise, simply you can detect or you can convey to the user that specific sensor is not available on your device. So we cannot collect data. And the thing is that why we should do this, that it is not possible that every device will have all type of sensors available. Already at the start of video we have discussed this point. That's why it's a responsibility of developer to check whether specific type of sensor is available or not before going for collection of data. Now these are the few examples, quick examples that I will try to show you. First example, we have how we can retrieve all type of sensors that are present within specific Android device. So for getting the list of all available sensor within the specific device, we have to use get sensor list method, and to this method we have to pass type all constant. So in order to get and store this sensor list, we will create the object of this list class of having type sensor. So list, and whatever object we are creating here, it will have the atoms of type sensor here. That's why in angle bracket we have specified it sensor. Then sensor manager, and its method we are using get sensor list. And as we have mentioned here, to this method we are passing the type all constant of sensor class, so which will return the all available sensors within the specific device. And then very simply we can iterate this particular object which contains the all available sensors. So here let's say we will use one string builder object within which we will keep appending the available atom within this object. So for that purpose we are using here for loop. So sensor, this is the temporary variable, colon, and which list we want to iterate. So we want to iterate the device sensors, and here I will use temp variable. So this for loop will iterate all the atoms available within this device sensors, and in every iteration the atom will be available within the temp variable of type sensor. Now within this for loop we are using the object of string builder and its method append. So let's say this is string builder. Okay, now this is the string builder object. So in this object we will append the sensor name one by one, whatever list of sensor will be available. So in the first iteration, first atom from this device sensors will be available in temp, and we will append the value of temp within the string builder. This is your string builder. So it has one method, append method. So string builder dot append, and here I will change temp. So temp dot get name method will return the name of sensor. So whatever atom will be available in the temp variable, so the name of that item can be written, the name of that sensor can be written with help of get name method. Okay, so likewise this for loop will iterate through all the sensors that are available in this device sensors object, and it will appended one by one within this list like this. So we will also see how we can do this practically. Same code we are going to use within our program. And at last, whatever string builder value we will get at the end, we will simply assign that value, or we will simply display that value to certain text view. So let's say my text is object and set text is its method, and we will pass the object of string builder over here. String builder dot toString method we can use for converting the string builder to the string. So it will be displayed within the text view. Okay. So this is basically the logic for displaying all sensors that are available. So you can later on find out specific value, and you will be able to get the idea which sensors are available in that device. Now next very important and very basic thing, checking the availability of specific sensor in the device. So how we will do that? So as usual, you will create the sensor manager object and you will get the sensor service, and then using this if else block you will be able to check it. So in if you will write sensor manager get default sensor, and which type of sensor you want to check here, you want to check the type light sensor. If it is not equal to null, that means sensor is present. So you can collect data over here, you can collect data because sensor is present. Else failure, so no light sensor, you cannot collect data. So here you can display message to user that on your device specific sensor is not available. So this is how you can determine any type of sensor. Just you have to replace here the specific type of sensor whichever you want to determine. Now let's try to understand what steps you will follow in implementation of sensors. First step, we have creating the instance of sensor manager class. So how you will create it? So simply you will write sensor manager sm, any object name you may specify. So you should declare it at the top of your class, so in different methods it will be accessible. So at top of class you should declare this object of sensor manager class. Second step, you will take calling the get system service method, and to this method we will pass sensor service as a argument. So we will be able to use the sensor service of the Android operating system. See here the example of second step. So SM is an object of sensor manager and get system service is a method. We are passing the sensor service as a parameter, and here we are typecasting the result. Whatever result this method will return, this result will be typecasted in sensor manager type. Why? Because here we are assigning value to the SM object, and what is type of SM? The type of SM is sensor manager. Okay, so this is the second step. And third step, perform the event handling. So here in event handling, two methods we discuss, on accuracy change and on sensor change. Both of these methods we need to specify within our code, and here we can write the logic whenever, let's say, accuracy of sensor will change, and here we can write the logic when the value of sensor will get changed. So here one example we have given, whenever the value of sensor will be changed, how you will retrieve the value. So one variable we will create here. Let's say we have the sensor of type light, then it returns value in form of lux. So we are creating one variable here, lux, and event is an object that you can see here. Sensor event is a class and event is an object. So this event object contains all the data that sensor has written, raw data. So here you can see event dot values, and it is available in form of array. So first atom we want to receive, first atom we want to use, that's why values of 0. So sensor may return different types of values according to different axes. Let's say you have accelerometer sensor, so it will return 3 values. How you will receive that 3 values here? So you may create 3 variables. So you may create, let's say, float x, event dot values, and first value will be available at 0. Then in the same way you will declare float y is equal to event dot values, and here you will specify first, and last one float, here as well spelling mistake was there, float z is equal to event dot values 2, like this. So depend on which type of sensor you are working with, you can receive different number of values. So remember this, let's say for accelerometer sensor 3 values you will receive, for type light sensor 1 value you will receive, for proximity sensor 1 value you will receive. Like that you can receive the values from sensor in form of variables. Okay, so here you need to remember the object of sensor event class you need to use for retrieving the data, raw data from the sensor. So these are the two methods that you will implement in the event handling part in the third step. Now last part, that is example. So two examples I am going to show you. First example is displaying all available sensors in our mobile phone, and second example, that is how we can use type light sensor that will detect the available light in the ambient environment, and second one, type accelerometer sensor. We can also understand proximity sensor as well. So these two examples I am going to show you practically. Before moving forward, I will show you the list of available sensors in Android. So this list I have referred from the official website of Android. So here you can see the list contains 13 number of sensors. These are the official names of sensors that you can use in your program. This is the type of sensor, whether the implementation of sensor is hardware or software, that we have discussed. This is the description, what that specific sensor is doing, and common use, where that sensor is commonly used. So here in the example you see there is a type accelerometer, its implementation is hardware, and this sensor basically measures the acceleration force in meter per second square, and the force is measured along all three physical axes xyz, including the force of the gravity, and where it is used for detecting the motion of device like shaking or tilt. Second, you have type ambient temperature. So implementation is hardware and it measures the ambient temperature in form of Celsius. Okay, so use you can see for monitoring the air temperature. So likewise different sensors we have. So here let's say we have type light, implementation is hardware and it measures the ambient light level, so in form of lux. So it is used for controlling the brightness of the screen. So based on the value that is sensor is retaining, you can control the brightness of your screen. So likewise there are different sensors available. So you can take screenshot of this. I will keep it for few seconds so you can learn them and you can use them. Next to that, you can also take screenshot of this. Here it is type proximity sensor. So it is used for measuring the proximity of an object in centimeter relative to the view screen of the device, and where it is used. So it is used for determining the phone position during the call. So whenever you will keep your phone near to your ears, so screen will get off, and whenever you will take it away from your ear, the screen will get turn on again. So that can be done with help of this proximity sensor. Okay, so same example they have described here. So I hope you have taken the screenshot. Now I will move to the Android Studio. Now friends, here already I have created one project called sensor video demo, and I got these two files, Java file and XML file. So quickly I will move to the XML file, and here I will change the GUI. Okay, so here I am going to change the text of this hello world. So here I will say sensor demo. Okay, and text size I will increase little bit. So this is how it is looking. Now next to that, one text view we are going to add here, and within this text view, friends, we will display all the available sensors. Okay, now I will change the size of this text view like this, which will span the complete screen, so majority of sensors will be visible. And here I will remove this. Okay, now you can see this text view is blank. Here we are going to display all the list of our sensors. So this is our text view. Now designing part is completed. Now come to Java file. So first of all, step number 1 we will perform. Create object. So here we have one text view. Let's say TV will be our object. Step number 2, fetch the reference. So here we will write TV is equal to text view, find view by ID, r.id dot text view 2. Let me check whether I am referring correct text view or not. So this is our text view. So it shouldn't be text view 2, it should be text view. Okay. Now friends, step number 3 is creating the object of sensor manager class. Create the object of sensor manager class. So here I will write sensor manager sm is equal to sensor manager get system service context sensor service. So here we need to import this class. So this is the step number 3. We have created the object of sensor manager. Next to that, create the object of list. We want to display all the sensors. So here step number 4, create the object of list class. So here I will write list. In angle bracket I will write sensor my sensors, any object name you may specify, is equal to sensor manager dot get sensor list, and in which we will pass the constant type all. So I will write sensor dot type underscore all. Okay, now next to that we are going to use our for loop for iterating through this object. So here I will write for sensor any temporary object you may create and specify the object of list over here, and within this now we want to append the all available sensor names. So for that purpose we will create one string builder object here. So I will start typing string builder sb is equal to new string builder. Okay, now within this string builder we will append all our results. So I will write sb.append. So here you can see in the suggestion it has given temp.getName. Okay, and here I will add the +/n for new line. So every sensor name will be appended on new line. So this is how we have written the logic. Now next to that we want to display all these available sensors on text view. So I will use here the object tv.setText, and here we will write sb.toString. So string builder to string we have converted. This is the logic, friends, which will display all the available sensors on our device. Now I will quickly run this code and show you what output we will get. Now first of all I will connect my mobile phone to computer. So friends, here you can see my phone is connected, and now I will run the app. Now here the building process is going on. So here now it is installing the application. So I will tab on install. And now friends, you can see we are getting the list of all available sensors here. So you here importantly you can observe gravity sensor is there, linear acceleration sensor, rotation vector, step detector, step counter. So all these different type of sensors available here within my device. In the same way, device to device the list will get changed. Okay, now friends, we will move further and I will show you the second example how I can use the type light sensor and type accelerometer sensor within the same code. So here already we have created the object of sensor manager. Now I will change the code over here. So here I will write code for type light sensor, type light sensor. So let's create the object of sensor class. So sensor, let's say sensor light is equal to sensor manager dot get default sensor, and here we have to pass the type of sensor. Which type of sensor? Type light sensor. Okay, so this is how we have created the first sensor. In the same way we can create the second sensor. Whichever number of sensors you want, you can create them in the same way. So for example, I want to create the accelerometer sensor. So how I can create? So I will write here sensor, let's say accelerometer sensor is equal to sensor manager dot get default sensor type accelerometer. This is how. So you can create any type of sensor like this, and you can use this sensor object later on for retrieving the values. Okay, so here we have created two two type of sensors. Now next to that, we have to write code for event handling. So here we will write code for event handling. So for registering the event listener for sensor, we will write sm, that is sensor manager dot register listener, and here we will write new sensor event listener. And you can see now, whenever we will hit enter, we will get two methods as a implementation, on sensor change and on accuracy change. Both of these methods are available here, and here we need to pass certain parameters. So first parameter is the type of sensor. Which type of sensor here we want to use? So let's say we want to use the first sensor, let's say sensor light, type light we want to use. So this object name I will pass here. So I will write here sensor light, and comma we will write the delay, by what amount of time you want to receive the data from sensor. So I will write here sm sensor delay normal. So there are different type of delays available, so normal delay we will use here. And now here we can write the logic within the on sensor change method. So we are implementing the type light sensor, so one value that sensor will return, so we will receive that value now here. So let's create one variable float, let's say light value is equal to, now we will use the sensor event class object. So sensor event dot values and 0, one value it returns, and simply I will display it using certain toast message. Toast, the light value is and plus string dot value of, and here I should pass light value, and I will change the length to long. This is the thing we have done. You can also do many things here by checking the value in specific range, and then you can display it accordingly. Okay, so I am simply displaying the value of sensor here. Okay, so again I will launch the project. So this button I will use, so it will apply the changes and rerun. So it is applying changes, and here you can see the toast message which is displaying the value of light. Now friends, I am moving my hand near to the phone, so you see the light value is getting decreased, and now I will completely place my hand on the phone. Now you can see the light value is 0, so no light is coming towards the sensor. It is unable to recognize the light. Now I will slowly move my hand from my device. Now you can see now light value is increasing, it is changing. Now I will move my phone in the brighter area of my room, so you will be able to see the value of light is high. Now you can see I am moving it towards the brighter area. Now I will again move it to its original location. So like this, the light value can be received using the sensor. Now next change, we are going to show you how to use the type accelerometer sensors. Already we have implemented this code. Only I am going to change here now the type of sensor here. Instead of this sensor light, I am going to use accelerometer sensor object. Okay, accelerometer sensor. And here, as you know now, three values it returns. So that three values I am going to display in the logcat. So I will comment this code, and now I will write on next line float x first value is equal to sensor event dot values, and first x value is available in 0 location, 0 index value. So I will copy this, paste one more time for z. So let's change now x, y and z, and here it will be respectively 1 and 2. So here we will create the toast message, and here I will write x value plus string dot value of x. Next to that, I will copy this line and we will paste it 3 times. So this is y value, this is z value, and here we will have y and z. So this is how we have displayed these three values from the accelerometer sensor. Now friends, again I will use this button, apply changes and restart activity. So whatever changes we have made, it will be reflected. So again I will rerun this project. Now here you can see we are getting three values x, y, z. Okay, but that values are displayed in very fast manner. So I will change this delay. By applying changes. Now you can see here the value of accelerometer sensor x, y and z. So if I change the phone, you can see now the values are getting changed. Same values we can also displayed in the logcat. I will try to show you. Here I will write log.d, tag will be x equals to comma. Here we will display string dot value of x, and I will copy this, copy, paste it for y and z, y, z, here will be y, here will be z. Now friends, I will rerun this. So in logcat I will be able to show you three values. So here if you are able to see, these are the value: x value, y value and z value. Now I will change the position of the device, and now you will see you will receive different value. Now you see here, you will see here you are receiving different value for xyz. If I will change the orientation or the position, you can see again you are receiving different value. Like this you will be able to receive the different value. Okay, now in the same way friends, you can implement the proximity sensor as well. Here only you will create the object of proximity sensor, and here you will pass the object of that sensor, and accordingly here you will receive single value like we have received. So any of these shown sensor can be implemented in the same way. So friends, this is how we have seen the concept of sensor in Android. Friends, if you find this video useful, please like and share this video, and as well as subscribe our channel. I will see you in next video. Thank you for watching.